Well, a few weeks ago I bought one of these, but unfortunately I haven't had a chance to use it yet, and the reason being it also came with one of these. Then I think you're probably going to need one of these. So what I've got for us to look at today is this step-down transformer. Now the main reason that I decided to buy this is because just recently I've been buying quite a lot of equipment from America. So my understanding between the domestic supply that you find in the UK and in America, well, for one thing, typically for small equipment the Americans use 110 volts equipment. They also run a two-phase system so they can have two 20-volt outlets, and I think those are used for things like tumble dryers or cookers, or basically anything that requires more power than you could get from the 110 volt supply. The other important difference is in America they use 60 Hz and in the UK we use a 50 Hz supply. Now for many types of equipment the difference between 50 and 60 Hz won't make any difference. A transformer doesn't care. A transformer will work just as happily at 60 Hz as it will at 50 and vice versa. But there is equipment, maybe things that contain electric motors, maybe turntable decks or things like that, where they may use a synchronous motor or maybe a fan motor or something like that. And maybe, for example, if you bought a clock from the United States, it would be designed to be locked to the line frequency, which is 60 Hz. So if you actually run it at 50 Hz, it's going to run slowly. But just for clarification, this unit here just converts from 230 volts to 110. It doesn't do anything with the frequency. So the model number for our transformer is a VTF 1500. And as for the maker's name, well, your guess is as good as mine. I'm going to go for LVYUAN. LVYUAN. Does that sound about right? I've got no idea. There's one or two too many consonants there, isn't there? So the manufacturers do supply us with a manual, which is just a single sheet of paper. And of course, we're not actually going to read that because, well, it's better to make mistakes, isn't it? You learn that way. So the unit that you can see here, I bought it via Amazon Prime and I paid £49.50 for it. If you do go and have a look on the Amazon website, you'll see that there's quite a few different units available, and it seems to be mainly down to the output power. So the rated output power for this particular piece of equipment is 1500 VA, and it is important to say that that is a VA rating, so that's apparent power. Now the VA rating of this device is really down to the size of the transformer and its efficiency. The more money you pay, the bigger the transformer and the higher the VA rating it will have. So when choosing this device, I thought that 1500 VA would be more than adequate for any piece of test gear I'm likely to plug into it. Now I think the way the manufacturers have specified this output power rating is a little disingenuous. The 1500 is actually the peak output power, and the manufacturers actually say that you need to apply a 50% derating factor. So the actual steady state output for this is only 750 VA. So for anybody thinking of buying one of these, before you do so, you need to look at the power rating of the piece of equipment you intend to supply, and then when you choose a transformer you need to choose something that's got about double the power rating. So I can see on the front of the unit we've got a large toggle switch, so I'm guessing that's going to switch the power on and off, and it does look a little bit like one of them that's an illuminated rocker switch, but I'm not sure. It's also got a power indicator LED at the top. And we've got a variety of plug sockets here. So we've got some that are labelled 220 and we've got some that are labelled 110. So I'm guessing that the 220 volt sockets, they're just straight through, they're fed from the line input. And then with the two sockets at the bottom here, they're going to be the transformer output, so they're at 110 volts. So I guess my first check is just going to be that my American plug will actually fit into here, which it does. So if we just take a look at our American outlet socket here, we've got 3 pins. So the top pin here in the middle, that's going to be our earth return. Now the pin on the left, that's our hot wire, and would normally be connected to a black cable in America. And the slot on the right here, that's our neutral, and that would normally be a white wire in America. Now I don't know if you can see, but these are live and neutral slots. They're not actually identical. The neutral slot here, the white wire, is deeper, so these connectors are in fact polarized. So this is the American plug that we looked at earlier, and it's actually just one type of plug, this, in that it's non-polarized. And the way I can tell it's non-polarized, if we look at both the prongs here, they're actually both the same width. if this was a polarised connector, you would actually find that the neutral side, the neutral prong, would actually be slightly wider. Well, these are actually both the same width. The other kind of giveaway is probably that both the line cords coming out of it, they're both grey coloured, so you couldn't immediately look at this and work out which one was the live and which one is the neutral. So this is a non-polarised connector. And another obvious thing about this connector, you can see it's only got 2 pins. Again, we've got a live and a neutral. What we've got missing here is the earth pin. So this piece of equipment that we would be using is not earth. So here's another type of American plug, and you can see that this one's actually got 3 pins on it. So we've got an earth pin here, and then these pins will be the live and the neutral. Just looking at it, I'm not sure which way around it is. And although the actual pins are the same width on here, we don't actually have a neutral polarizing pin like I mentioned earlier. Just the fact that it's got 3 pins means that you can only insert it into the socket one way around anyway. So this is the type of plug that we commonly use in the UK, and this is a British Standard 1363 plug. So let's just see how well it fits. Actually, that goes in solidly, feels tight, no problem with that, feels good. So on these British style plug sockets, you can also see that we've got some safety shutters. So if I actually try to poke something inside, I can't actually make any contact with live parts. And what you've got to do is, of course, you've got to actually put the earth pin in first, which opens up the shutter. So the fact that they bothered to put these safety shutters on is actually a really nice feature, because they quite often don't bother with some of these cheap British style sockets. Let's just turn the unit around and have a quick look at its bottom. So the unit that we bought here doesn't just step down from 230 to 110, it will actually step up the other way. So you can actually take this unit to America and actually power up 230 volt equipment with it. But what you'd have to do is you'd have to set the input line voltage to, well, I think in America it's actually 115 volts, isn't it? So let's just try that. So if you're in America, you would set this to 115, but here in the UK, where our supply voltage, our input voltage to the unit, it's going to be 230, so we need that switch over here. And as I bought this, it was in the correct position, it was set to 230 volts. So we've also got 2 circuit breakers mounted on the back panel, and that's a really nice feature because of course they could have just put fuses in there. I'm guessing they gave us circuit breakers because it's not unlikely for somebody to plug in the wrong type of equipment and maybe constantly blow fuses or overload the transformer. So they've actually given us some circuit breakers, which again, it's a really nice feature. So we've actually got an output breaker here for the 220 volt circuit, and they've given us a circuit breaker for the 110 volt circuit. So that's good. And because the equipment is CE marked, we can of course rest comfortably that the equipment is going to be safe and comply with the relevant British standards. Well, you could do that if you wanted, but I'm not going to. Let's test it. So what we're going to be doing here is we're actually going to be doing an insulation resistance test. So we're going to supply a high voltage to both the live and neutral pins at the same time, and we're actually going to look for any leakage onto the earth pin. So that's an insulation test. The other thing we're going to do is we're going to see how good the earth bonding is on the piece of equipment. So we want to make sure that if there is a fault inside and a live wire touches the case, we want to know that the wiring here is suitably rated so that the fault will go to ground and it will trip out the main circuit breaker and disconnect the device. So we're also going to do this earth impedance test as well. Now, to do our earth impedance test, I actually have to clip onto a metal part on the side of the transformer. So I'm just going to choose one of the screws and assume that that's going to have a good connection. And before we do the test, it's important that our transformer is actually turned on, so let's just check that. That's off. That's on. So my Claire tester here has a couple of different ranges we can use. It has this 0.5 ohm for earth circuit test, and it does that at 500 volts for insulation. And then it's got another setting over here where it actually looks for kind of a higher safety standard, so it's looking for less than 0.1 of an ohm for our earth cable, and it's going to do the flash test at 1250 volts. But let's see if it passes the lower test first. So it passed that, no problem. And let's try the higher test here. So we're now at 1250 volts and 0.1 ohm. and it passes that too. So we can be fairly confident here that the insulation is good on our transformer, and that we do have a really good earth connection between the outer case of the piece of equipment and the earth wire back to our plug socket. So if we get a fault, it should trip the circuit breaker or blow the fuse in our plug, and we will be protected. Well, it's certainly got a lot of screws, so I'll be bringing out my old friend Mr. Electric Screwdriver. But taking a look inside, there really isn't an awful lot to see because it's quite a simple piece of equipment. It is really just a transformer and some output sockets. So if we just tip the unit onto one side, you can see that we've got an earth stud here. So the actual line cord comes into the unit and it gets earthed to the chassis, and then we've got another wire which is feeding the sockets on the front here with the earth. Now I can see that the 230 volt are British style output sockets here. These have got screw connectors on them. So yeah, nothing wrong with that. The wires go into it and they're screwed in, look, firmly. But the American style connectors on the bottom, they actually are a solder connector, and the wires are just soldered on. And well, you know, it would be very possible for me to get my fingers in here and possibly get an electric shock off something. They have put some little bits of heat shrink on various places, but yeah, if you took the cover off it, you could be exposed yourself to an electric shock quite easily. So none of these connectors are actually touch proof. There is some heat shrink on it, but they haven't really done a very good job of heat shrinking it. So it looks like these connectors are actually held in with kind of barbs on the side of them, but everything has also been rather generously covered in hot snot glue. I don't actually mind that, it's better than things coming out. So if you just look at the back of the unit, these connections are to the mains voltage selector, and again there's actually no heat shrink and no protection on here. Now of course we shouldn't be operating a piece of equipment with the cover removed, but well, you know, I would have liked to have seen this touch proof, because again you get quite a nasty electric shock if you happen to touch these. So you can see that the incoming line cord is actually earthed to the chassis and then it goes off to the front sockets, but this is the top cover that I've just removed, and there's not actually any connection between here and the top cover. I would like to see an earth wire between this chassis point and the top cover, because at the moment it is actually relying on the actual metal connection, the screws. It's actually relying on the screw fixings to provide the earthing for this top cover. That's not really a very good way of doing it, because as you can see these have actually got paint on them. Now as it happens, I can clearly see that, you know, the paint has been scratched off as the screws have entered into it, but that's more by luck than judgment. So really what you would want to see is you'd want to see an earth wire between this top cover here and here, so that it always remains connected, because what could happen is a wire could come off here, it could touch the side of the unit, you put your hand on it and you receive a really nasty or fatal electric shock. So this cover must be earthed. So what I think we'll do with that is we'll actually just disconnect here, and I'm going to put an earth wire in. I'm going to put a short link wire between this earth stud and the top cover. We'll scratch the paint off over here, and then we can actually guarantee that this top cover is going to be earthed. It is belt and braces, but it's the best way to do it. Now earlier I did perform that electrical safety test, but I actually did it to one of the screws on the side of the casing. It probably would have been more sensible to have done it off these, because that would have actually proven if this case was properly earthed. I suspect if I had done it to these fixings here, we would have got a fail, because there is a lot of paint on all this. But of course I didn't know the way this was assembled before I actually did the testing. I've only just seen this now. So we'll put the earth wire on, and that should be a bit safer. So I'm just going to clean this up using some abrasive paper, because I want to remove all the paint so we can get a good metal to metal connection. So I was just about to remove this bolted connection to fit our new earth wire, and when I tipped up the equipment I noticed that the actual earth wire here, it doesn't go to a bolt or anything on the bottom. What it's actually going to, well, it is going to a bolt, but it's actually going to one of the feet. Now that is not correct. It is part of the legislation, I'm pretty sure, that says that if you're using an earthing stud, it has to be a dedicated earthing stud. It can't just be a bolt that's holding the case together. And the rationale behind that is that somebody could lose or knock the foot off this, or take the foot off. And if they did do that, they would actually lose the earthing on the piece of equipment. So you must not use fixings for the purpose other than what they were intended for. If you want to earth the case of here, what you should actually do is you should actually drill a hole in it, and we should actually use a separate earth stud. We shouldn't use one of the fixings which is being used to hold on the feet. That is wrong, so that's a fail. So just looking at the back of this transformer, you can actually see that it's actually got this CE mark, although some people say that stands for China Engineering, but what they're trying to say is it's CE marked. If it's CE marked, it should be safe and it should comply with the appropriate electrical standards. Well, just looking at it, I'm 100% sure that it doesn't comply with the electrical standards, certainly not for today anyway. Now, would I still use this piece of equipment? Yes, I would, because I've got enough knowledge to keep myself safe. But I think the fact that it's not earthed correctly here, and perhaps some of these exposed terminals or the risk posed by this, that just doesn't comply with the standards. So yeah, I think what I will do is I will actually write to the manufacturer and I will just point that out to them and see if they respond. I don't expect them to, but well, if you find something you should at least report it, and then maybe somebody can take action. So I've just gone ahead and I've drilled a new hole here in the bottom of our chassis, and I've scraped the old paint away to expose a nice bright and clean surface that should make a very good electrical connection. I also scraped the paint away on the underneath side as well. So on the original grounding point you can see we've got a star washer, and the whole purpose of this star washer is to actually bite deeply into the metal, but unfortunately it's been assembled on top of a load of glue, so yeah, I don't know if it makes a good contact or not is the honest answer. So again, kind of note to self, when you assemble these things, don't actually assemble them onto a lot of glue, because glue is an insulator. So now we've gone ahead and fitted our earth strap, we no longer have to rely on the fixing bolts making contact through the painted surface for our electrical safety. Now, having spent about 5 minutes berating the manufacturer for using the bolt that holds the feet on as the main earthing stud, did you see that I went ahead and I did something just as stupid? And I've installed a strap between the main earthing stud on this top cover, but what I actually fastened it down to was this bolt here, which is actually designed to hold the handle on. Well, I shouldn't have done that. Of course, what I should have done is I should have drilled a separate hole in this top cover and actually fixed a bolt on there just for the purposes of earthing. Because the problem is, somebody might, for reasons unknown in the future, decide to take this handle off. And if they do decide to take the handle off, my earth wire will fall off it. And potentially that will leave this top cover unprotected, unearthed. So if a wire comes off and touches the side of the cover here, that could become live. Silly mistake. What I will do is, off camera, I'm going to go ahead, I'm going to drill a hole in here and I will fix on a dedicated earthing bolt, and we'll go ahead and we'll retest it. And that passes absolutely no problem. And on the meter here it's just displaying our earth continuity, which is less than 0.02 of an ohm, so we have a really good earth connection to the cover of our piece of equipment here. So really there's nothing really very exciting about this, because all it actually is it's a step down transformer. So we put 230 volts in at one end, and at the other end we get 110 volts out. I've actually drawn a conventional transformer here, but it's unlikely that it is a conventional transformer. More likely what we have in this little black box is what they call an auto transformer, so I'll just draw it as an auto transformer. There's a load of windings. And then really an auto transformer, it's just one winding, so we don't have a primary and secondary as such. what we have is just one big winding, and this will be centre tapped about halfway along the length of that winding. So again, we'll put our 230 volt in and we'll get our 110 volt out there. Of course, this has a primary and a secondary, and this kind of has one big primary winding and kind of a secondary across there. So for this type of transformer, I would say that probably the main advantage is the fact that it's an isolating transformer. The actual secondary windings aren't connected to the primary, so the secondary output voltage here, this 110 volts, it's isolated from the mains 230 volt supply, and in certain situations, in fact in many situations, that makes it safer. Under various fault conditions, it's less likely that a piece of equipment on this side of the transformer is going to get exposed to the incoming line voltage at 230 volts. So probably the main disadvantage of our auto transformer is this lack of isolation, and by that I mean if you look at the live output wire here, so this is L, so we've got the input here and the output there, and these are both the live connections. If you look at the live connection for the output voltage, you look, it's connected here effectively to the live input, and it's just connected via a length of wire. Admittedly it's a coil, but it is a direct connection, so basically you're not isolated from the mains. If you was to touch this live wire here, you would get a belt. You could get certain situations where maybe you get some shorted windings in here, and again you could actually more easily directly connect this live input to the output, so more likely to get a failure, and if we do get a failure, the lack of isolation means it's less safe. But having mentioned these disadvantages, the big advantage of the auto transformer, well, one of the main advantages of it, if you don't need isolation, the big advantage is that it's much cheaper, because we've only got one copper winding here, so there's much less copper in it, and typically there'll be about 50% less copper. Copper's very expensive, so an auto transformer will probably cost about 50% the price of a standard transformer, and that's a big advantage, isn't it? So just a moment ago I mentioned that our step down transformer here is likely to be an auto transformer, and because it's an auto transformer there is no isolation between the primary winding and the secondary winding. And under certain situations that could actually be quite dangerous, but just to prove that lack of isolation we can do that very easily. So I'll just take a crocodile clip here. I'm going to clip on the ohm meter to the effectively the primary side of the transformer, which is just the 13 amp plug here, because that's connected to the primary, and then the secondary here is the 110 volt output. So I'm just going to stick a long probe in there, and you can see we've actually got about 2.5 ohms, 2.4 ohms, 2.3 ohms even. So we've got just 2.3 ohms between the actual primary side and the secondary side. So in this application there is absolutely nothing wrong with using an auto transformer. It's actually probably the perfect application for it. That it really isn't a big deal if we have a fault, and well, the worst that can happen is we can get 220 volts put on our 110 volt output. It may damage the piece of equipment that's connected to it, or it may just blow a fuse, but it's unlikely to result in an injury to anybody. So for this type of application, the fact that they can make the transformer much smaller, much more cheaply, and it also has advantages in terms of efficiency and voltage regulation, it's an all-round winner. But there is very many applications where an auto transformer would be absolutely the worst thing to use.